Hi, my name is Sharif Ismail. I'm an English language fellow here in Mongolia, and today we're going to be discussing electrical engineering. Electrical engineering, what do we see here in the picture? We see some people who are electrical engineers and they're working on different electrical components or electrical platforms. Electrical engineering, it's two words. The word electric or electrical or electricity and engineering. So you could guess that electrical engineers um, or electrical engineering is a branch of engineering that focuses on the study and application of electricity, electronics, and electromagnetism. Electrical engineers work with various electrical and electronic systems, devices, and technologies to design, develop, test, and maintain them. They are responsible for creating and improving electrical and electronic systems that are used in wide range of applications, including power generations and distribution, telecommunications, electronics, computer systems, control systems, and more. And pretty much because many devices rely on power to work, then electrical engineers are involved in mostly everything around us, including computers, drones, cell phones, anything that needs power or electricity. We have some words here from the book. We have the word integrated circle, input voltage, power supply, and a circuit. And here we're going to be looking at each one separately. First, we need to understand what is electricity and why the word electricity is named electricity. The word electricity comes from the word electron. And when we look at any atom around us in the space has electrons and protons. Electrons have negative charge, while protons have positive charge. This flow of electrons produces energy that we use in electricity, which what we call electric current. And that's why we call it electricity, based on the word electrons. Here we see a rush of electrons within a wire, and the electrons are within an atom. So there's an energy flow within a wire that's produced from the movement of electrons inside an atom inside the wire. Here we have a conductor, which is copper wire. It's a conducting material. Remember, we talked before about the difference between conducting materials and insulating materials. Here we have the nucleus of the atom, we have the electrons, and here we have insulated sheath, which is insulator that protects the electrons from escaping outside the wire. And here, of course, we have the electrons that provide us with the electrical power or energy. Let's look at a circuit. What is a circuit? In electronics, a circuit is a complete circular path that electricity flows through. So here we have an example of a circuit, and the electricity flows around the circuit. Here we have some symbols that people use in a circuit, for example, a battery, cell, fuse, and here we have an example of an electrical circuit with a switch, power supply, and a lamp. We also have an integrated circuit. We have two words, integrated circle. That means it can be integrated into uh, this board. An integrated circuit is a set of electronic circuits on a small flat piece of semiconductor material, usually silicon. Large numbers of miniaturized transistors and other electronic components are integrated together on the chip. These are some examples of ICs or integrated circuits. We can see this in a computer motherboard if you want to change the memory card or if you want to change the hard disk. These also would be called integrated circuits. Also, we have the circuit card assembly, which is a card that you can assemble most of your electric components in it. A good example for that would be the flash memory drive that you use on your computer. Also, we need to here to talk about voltage. What is voltage? Voltage, also known as electrical potential, is the pressure from an electrical circuit's power source that pushes charged electrons or current through a conducting loop, enabling them to do work such as illuminating a light. So here we have an example with the water pressure. If we have a lot of water here, then there's a lot of pressure, right? There's high pressure. If you have little water, then you have low pressure. This is the flow of water. So it's very similar to voltage. Okay. So voltage is the pressure of electrons inside a circle, inside a circuit. Okay. Here we have high potential, high voltage. Okay. Here we have low voltage. Also, we need to look at the difference between voltage, ampere, ohms, and watt. If we refer to the water pressure in a pipe, then that would be the voltage, the pressure. Sometimes when you turn on the water from your in the shower, if the pressure is not good enough, you can't take a shower. So water pressure is the same as the voltage for electricity. The voltage needs to be pressurized enough to produce enough power. Water flow or ampere. Also, the water should be flowing, and we measure this with ampere. Pipe size, if the pipe is smaller, then the pressure is going to be stronger. If it's bigger, the pressure might be less, or it depends. But we can compare to the pipe size to the electric wire size, and we measure this with ohms or resistance. The energy created, which is the watt, how much energy is being produced in the pipe or in the wire. That's what we refer to as the watt. The input voltage. The input voltage is the voltage you supply to the board into a linear voltage regulator. We have input voltage and output voltage. Power supply is, as you see, this says power supply. So it's electrical device that supplies electrical power to electrical load. The main purpose of the power supply is to convert electrical current from the source to a correct voltage, current, and frequency to the power load. Certain items they require certain voltage, certain current, and certain frequency in order for it to work. For example, if you have a small lamp, it requires different voltage from a bigger lamp. So the power supply decides all of that. The headlights of your car, they require different voltage from the light bulb in your room. And again, the power supply provides the enough voltage or current or frequency that is good enough to get these items to work. Here we have a quiz. You can pause the video, read these questions, and choose the correct answer. Now you pause the video and you chose the correct answer. I want you to check your answers and see if you got the right answers. That's it for today. Thank you for listening to this video, and I'll see you next time.